Welcome to The Explainer. So, today we're diving into something pretty radical in the AI space. It's a new C++ library called Weed, and it's basically asking us to rethink everything about the tools we use to build AI.
We all know the big names, right? PyTorch, TensorFlow, the frameworks that have powered this whole AI revolution. And they've let us do some amazing things, for sure.
But what if there's a hidden cost? What if all these tools are built on decisions that were made like 10 years ago? This is what the folks behind Weed are arguing. They're saying this creates a kind of technological drag on the whole industry.
Okay, so this leads us to what you could call the AI framework paradox. It's this weird situation where we have these incredibly powerful tools, but at the same time, they're just tangled up in this huge mess of complexity and, honestly, bloat. Let's dig into that.
So let's start with the most obvious thing, size. We're talking about a disk footprint that can easily top 1 gigabyte. Think about that for a second. Over a gig of code and stuff you have to download just to get started.
And look, it's not just about how big these things are. It's about these crazy, complex dependency trees. What developers call dependency hell. It's about this clunky architecture where you've got a nice Python front end just sort of glued onto a C++ backend. And maybe the scariest part? Every single one of those dependencies is a potential security risk. We're talking a massive attack surface for supply chain hacks.
All right, so how do we fix this whole mess? Well, that's where Weed comes in. It's proposing a complete, radical refresh. The whole idea is to just rethink the entire stack from scratch. Get rid of all that baggage from the past.
And its core philosophy is something they call minimalist complete closure. Okay, what does that mean? It means giving you all the essential tools for serious AI work. Inference for making predictions, backpropagation for training models, but with absolutely none of the fluff. And the key part? No required external dependencies. At all.
So this is a totally fresh start, built on nothing but the C++ 1.1 standard. That's what makes it dependency-free. And make no mistake, this isn't some little toy for learning. It's built for real, production-grade performance. Sure, you can use it with GPUs through OpenCL and CUDA, but you don't have to. And that makes it an absolute game changer for small, embedded systems or super secure environments where you just can't have a whole Python setup.
Okay, so this is where it gets really, really cool. The big idea, the most innovative feature in Weed, it didn't come from AI at all. It came from a totally different field, quantum computing.
Yeah, that's right. The core design is literally pulled from a framework called QRack, which is a super high-performance simulator for quantum computers. QRack has all these clever tricks for optimization, and Weed basically just takes those same ideas and applies them to machine learning.
And you can see the mapping right here. It's a really direct parallel. In QRack, you've got a quantum state vector. In Weed, you've got a tensor. QRack gets its speed by transparently, and that's the key word, switching how it represents quantum states. Weed does the exact same thing, but for storing tensor data. And that's the genius of it, right? Taking this really advanced idea from a totally different field and realizing, hey, this solves one of our biggest headaches in AI.
So this gets us to the absolute key idea behind Weed, transparency. This one concept is what makes the whole approach so different and, frankly, so powerful.
This quote right here from their docs, it says it all. Sparseness should not be a tensor interface concern, but rather a storage concern. So what on earth does that mean? Well, think about it. In most frameworks, if you have a tensor that's mostly zeros, a sparse tensor, you have to use a totally different kind of object with a different API. It's a pain. Weed says that whole approach is just wrong.
And here's how their transparent workflow actually works. As a developer, you just use a normal tensor, like you always would. But under the hood, the library is being super smart. This storage layer automatically figures out the best way to hold the data. Is it a dense array? Is it a sparse hash map? It just picks the most efficient one. You, the developer, literally never have to think about it. It just works.
Now, of course, there's a trade-off. There always is, right? Weed uses what's called a hash map for its sparse tensors. If you compare that to traditional formats like CSR, yeah, it uses a little more memory for each element. But here's the kicker. Those old formats are super rigid. They're built for data that you set once and never touch again. Weed's approach is all about being dynamic. You can change elements on the fly, super fast. It's a totally different ballgame.
And this obsession with a clean, simple interface goes all the way down to the code itself. Get this, they overload the right shift operator to do matrix multiplication. So your code ends up looking like this beautiful, simple math equation. In C++, which can be notoriously wordy, that is a huge win for usability. It's just elegant.
Okay, so why are we getting so deep into these technical details? Because it all connects to a much bigger, almost philosophical idea about who's in control. It's something the creators call the sovereign AI stack.
AI sovereignty. The whole principle is about owning and controlling your entire AI stack. It's about breaking free from being locked into these gigantic, corporate-run frameworks. It's about building something that's truly yours, something that won't break just because some big company decides to kill a feature you rely on, or a hardware vendor changes their drivers.
And look at this. This chart really drives home one of the biggest practical benefits. When you slash your dependencies, you shrink your attack surface for supply chain hacks. The difference is just staggering. A normal Python AI stack has tons and tons of dependencies. Every single one is a potential backdoor. But the Wheat stack? It just relies on a C++ compiler and the operating system. That's it. It's so much more secure, so much easier to audit. And for anything important, critical applications, this isn't just nice to have, it's an absolute must.
So, that leaves us with a pretty big question to think about. As AI gets woven into every part of our lives, into our most critical infrastructure, WIDA makes us ask, who should actually own your tech stack? Are we going to keep building the future on top of these massive, complicated platforms controlled by a few companies? Or is it maybe time for a leaner, more transparent, and sovereign approach to become the real foundation for whatever comes next?